Scientists use the chemical formula for a reaction to help them calculate expected amounts of a product that can result from a reaction given a certain amount of the reactants. In order to predict the mass of product given a mass of each reactant, you must do the following calculations. First, use the molar mass of the reactant to convert mass of the reactant to moles of reactant. Then you can use the mole ratio to convert from moles of reactant to moles of product. Then you'll use the molar mass of the product to convert from moles of product to mass of the product. Sometimes in a word problem, you're told that one reactant is in excess. That means there's plenty of this ingredient and the amount of product is not dependent on the mass of that reactant. The reactant that is not in excess is the limiting reactant. Let's look at a problem with our ammonia reaction. What mass of ammonia can be produced in a reaction chamber that contains 250 grams of nitrogen gas and excess hydrogen gas? Here we're limited by an amount of nitrogen gas. We don't have to determine what the limiting reactant is because hydrogen is in excess. We do need our balanced chemical reaction as a place to start. Again, we're going to write the product to reactant mole ratio from the chemical reaction information. Our desired product, ammonia, and the reactant of interest, nitrogen, and that is our mole ratio that we're interested in. Remember, this is a mole ratio, so we can't just take 250 grams and multiply it by 2, where we use molar mass. Molar mass of nitrogen gas is 28.01 grams per mole. We get that from looking at the periodic table. Molar mass of ammonia. In our final step, we'll use the factor label method or dimensional analysis to calculate the amount of product that's possible to produce using the given reactant amount. We start with the only number we're given in the problem, 250 grams of nitrogen gas. We can't use the mole ratio just yet because we're in grams. We have to go from grams of nitrogen to moles of nitrogen first. That's why we use the molar mass of nitrogen gas. And I'm using it as a ratio this way because I want to get out of grams and into moles. So if I just did that calculation right there, I would have moles of nitrogen gas. Our next step is to use the mole ratio. I want to get out of moles of nitrogen and I want to get into moles of ammonia. So 2 NH3 here and 1 mole of N2 here. Our last step is to go from moles of ammonia to grams of ammonia. In 1 mole of ammonia, we have 17.03 grams of ammonia. Solve this, we'll multiply across and divide what's on the bottom. Ammonia that we can produce in grams, 304.0 And there we have it.